Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using trigonometry to find angles. So when you have a right angled triangle, if you know two of its side lengths, you can find any of its angles. So once again, we're going to use SOHCAHTOA to tell us which ratio to use. We use sine when the question involves opposite and hypotenuse. We use cos when the question gives us the adjacent and hypotenuse, and we use tan when the question gives us opposite and adjacent. But there is one thing that's different about this lesson than the previous lesson. In the past, we used sine, cos, or tan when we were finding sides. It turns out to find angles, you use sine inverse, cos inverse, or tan inverse. So you get these on your calculator usually by pressing the shift or second function button and then sine, cos, or tan. So if you wanted sine inverse on your calculator, you press second or shift, then sine, and this will come up. So these are the kinds of questions we're going to look at. In each of them, we're finding theta, we're finding the value of an angle. So in this first one here, we're given the opposite and the hypotenuse. So we're going to use sine, but because we're finding an angle, we're going to use sine inverse. So theta is just going to be sine inverse, and sine is opposite over hypotenuse. So we put this on our calculator, making sure we're in degrees mode. We get theta is about 35 degrees. So this angle must be 35 degrees. All right, let's look at this question here. So looking at theta, we have the opposite side and the adjacent side. So we're going to use tan, but of course, because we're finding an angle, I use tan inverse. So theta is tan inverse of opposite over adjacent. It's important you get which one goes on top and bottom correct, because tan is TOA, opposite goes on top, adjacent on the bottom. That's why it's 12 over 5. So if we put that on our calculator, it's about 67.38, which is 67 degrees to the nearest degree. All right, let's look at this one here. So we have theta here and our right angle over here. So 9.6 is adjacent to theta, 12 is the hypotenuse. So because we have adjacent and hypotenuse, we use cos. And because we're finding an angle, it's going to be cos inverse. So we have theta equals cos inverse of adjacent over hypotenuse, and we simply put this on our calculator. So again, to get this, probably need to press shift or second function, then cos, and put this straight on your calculator. So if we put that on our calculator, we get about 36.87, which is about 37 degrees to the nearest degree. All right, let's now look at a slightly harder question. So here we're given the question, triangle has side lengths 10, 10, 18 centimeters, calculate its largest angle. So just to help you with this, in any triangle, the largest angle is always opposite the longest side. Similarly, the smallest angle is always opposite the shortest side. So this is a worded question, so we know by now that we will draw the triangle, so we know what's going on. Now note 10 squared plus 10 squared does not equal 18 squared. This triangle here is isosceles, but it's most definitely not right angled. So it's going to look something like this. So these two sides are going to be equal, both equal to 10 centimeters, and this side here 18 centimeters. So we want to find its largest angle. So really, I'm looking for this angle here. I know it's going to be this one because it's opposite the largest angle. So the thing is, this is not right angled. We only know how to use trigonometry in a right angled triangle. But because the big triangle is isosceles, I can divide it into two congruent right angled triangles. So this side here will be 9 centimeters, half of 18. What I can do is find this angle here, I'll call alpha, then I just double it, and that will give me theta. That will give me the largest angle of the triangle. So what is this angle here, alpha? Well, notice I have the opposite side and the hypotenuse. So I'm going to use sine, but of course, because I'm finding an angle, I use sine inverse. So alpha is just going to be the sine inverse of opposite over hypotenuse. So putting that on the calculator, I get about 64.15 degrees. So that is this angle here. So the whole angle theta, this whole angle of the larger isosceles triangle would just be double that. It'll just be 64.15 times 2, so it'll be about 128.3 degrees. That is clearly the largest angle in this isosceles triangle. Of course, if you have an obtuse angle in a triangle, it's got to be the largest angle. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.